If you're watching this video on YouTube, you can watch on 1.5x speed.
So hello guys, this is Expert Panda and you're watching on YouTube. So let's understand today's question that we have 1466, right? And we are going to see reorder routes to make all paths lead to the city. Okay, so let's read the question. There are n cities numbered from 0 to n-1 and n-1 road such that there is you can say only one way to travel between two cities. Okay, and last year the Ministry of the Road decided to orient the road in one direction because they are too narrow. Okay, now roads are represented by connections, and where connections we have given is AI and BI, and from city A and city B. Now this year there will be a big event in the city, you can say. So so many people want to travel to the city, this city. Your task consists of reorienting some roads such that each city can visit the city 0 and return the minimum number of edges changed, and it's guaranteed that each city can reach city 0 after reorder. Okay, so as you can see, we have given this figure, right? What is happening here? See, it is first of all it's saying that we have n cities, right? So as you can see, example first n we have given is 6, correct? Now we have given it is saying number from 0 to n-1, means how many routes should be there from 0 to, it should be n-1 means 5, 0 to 5. So you can see total 5 nodes we have, 0, 1, 2, 3, 4 and 5, right? As per the example. Now it is saying such that there is only one way to travel between two cities. So if we want to go to city A to B, right, there is one way. Either we will go from A to B, right, and we will not go back, right, as you can see in this example. So if we are going from 2 to let's suppose we are going from 2 to 3, so this should be only one way, right? It is not should going to other way. And similarly we have, okay, so now what he is saying that that's all we have. Now it is saying okay, yeah, so this line you read. Okay, so this year there will be a big event in the city 0, right? So many people want to travel to this city. Okay, so okay, so I'm so sorry. Okay, so we are talking about so I said what I said that we have given n cities, right? So we have to we have total what, 0 to n-1, that is 0 to 5, and we can go only from A to B. Like the example we have given, if 2 is going, so you can see in the figure 2 is going to 3 in one way direction only. Okay, you cannot come like this from 1 to 2, 1 to 3 it is coming, right? You can't come. So if you are going from other way, this is only one way, right? One way, so you cannot come to another way. Okay, I think you got it. Now understand the requirement. Okay, so the question is saying that your task consists of reorienting some roads, right, and such that each city can visit the city 0. City 0 should be visited, no? And many people want to travel this city. So your task is to, what you have to do, you have to return the minimum number of edges changed. Okay, so what I'm going to see, first of all what we have to do, let me clean this. Okay, so now you can think, first of all, if someone is going to start from 2, right, and if he is going to in one way, he is going to 3, correct? From 3 he want to go to let's suppose 1, okay, and from 1 he can go to 0. That is very good, because we have to, everyone want to go to 0, right, 0 city. And from here you can see if anyone want to travel, right, so there is 4 is there and there is a 5 is there, correct? So how many edges is required to go, right? So if someone is coming from 4 to 5, right, this on one way is already there, right, if someone is coming from 5 to 4, and if 4 is coming to here, let's suppose here, right, then it's working. Actually this is required, right? But as you can see the figure, the red one is marked lateral, right? This one or this one, because these are opposite direction, right? And that's why what is happening here, we have to change this one. So this one way we are not going to consider, we will use this way, right, that we have marked here for our understanding, right? So this we have to follow to return then to go to the CTC in the capital, you can say, because this is a capital city, right? And that's why we have to update 3 edges, and that's why we have the output as 3. I think you got it. If you any doubt, please ping me in the comment box. Now we are going to understand here example 2, in which we have given 5 nodes, right? So we will be marked from 0 to 4, correct? So if you see that, right, from if you want to go, right, so this is our capital city, okay? So the capital city everyone want to go. If we have 1 2 3 4, right? So first we will start from 4, it will go to 3, 3 will go to 2, 2 will go to 1, and then 1 will go to this one. This is our one way, right? So for the one way we have to go like this, because this is our capital city, right? And this is not like that, right? So because 1 is going to here, correct, this way, and this is we have to remove, right? Similarly 3 is going to 4, this we have to remove. We have to mark this as one way, right? And we have to change the direction. That's why we are changing at here in the red mark and here, okay? And that's why we are required only 2 edges to change, right? And that's why we are going to see this one. So we have changed 2 directions here, and now our happy path is there, right? Everyone is going to capital. Now understand, if you have we have 3 given, and there is 1 we have, and there is a 0 we have, right? Okay, so this is the direction we have. Let's suppose 1 to 0, and there is 2 to 0, right? So this is already marked, so you don't need to change anything, so it's fine. I think you got it. If you have any doubt, please ping me in the comment box. I repeat, now understand, we have given n, so n is greater than or equal to 2, less than 5, and connection length should be n minus 1, and n equal to its length should be 2, right? If any direction we have, so at least 2 values should be there. As you can see, there is 2 pairs should be there, 2 pairs should be there. Similarly, every one is 2 pair, and that we have a and b greater than 0, n minus 1 it should be, and not equal to equal. This question has been asked in Amazon, right? American Express. Very top companies are asking this question, so it's related to DFS, you can say BFS, right? And hint is also given. So treat the graph as undirected and start with start a DFS from the root, and you come across the edge in the forward direction, you need to reverse the edges, correct? What is saying that you use the DFS. So we will start with the DFS, right? You can also use BFS, right? So if you like to do the BFS, please ping in the comment box, so I'll create another video for the breadth first search, right? And I'll help you there, okay? So I think you got it, everything, right? So what I'm trying to say, let's come to here. So see here in our solution, what we have given a you can say tree, correct? So this tree has n nodes, right? N nodes we have given, where you can say each node is a city, right? And this node is known as what? City. So if n node we have given, so it is marked from 0 to n minus 1, means if n equal to 6 we have given, so it will start from what? 0 to 5, that we have already seen, right? So the edges are referred to as roads, correct? And like if one node is going from, let's suppose I was talking about this is 3, right? And this is 2, okay? So if I'm going to write like this, 2 is going to 3, correct? Means this is our road, right? One way road, right? So this edge that connecting one node to another node, it is known as what? Edge, right? Between the you can say cities, right? So the tree that we have given in this problem has a directed edge, right? Means one way, okay? and that is called directed edge. Correct? This is our directed edge. Okay, so this directed edge is nothing but our given in where connections, right? There is a connection array, and connection array contains what? Each connection. So connections at some value, right? It is saying what? Connection at some value. It is what? Between A to B, correct? And AI and BI is a CT, right? Is a CT, right? And that's why this edge is given what? Where? Here, as you can see here, you can see connections contains what? 1 0 2 0, correct? That's why I'm saying that connection length is 2, and A and BI we have, right? It's not should be equal to this one, correct? Now think about like we need to return the number of edges, because connections we have given the edges, right? And we have given nodes also, right? So we need to return the number of edges that need to be flipped, so that every node you can say reach from 0 to you can reach to 0, right? So we have to flip that arrays, given nodes, right? These are the array nodes, right? So these nodes should be flipped, as you can say, and we have to mark the edges as different, right? So that we can trigger from one place to another place, right? So what we will do, first of all, let's suppose if we have some solution, right? Before moving to the solution, right, let's consider some terminology, right? So if one root is there, let's suppose this is our 0, okay, and we have some children of this node, so this is called our root node. I think you already understood, correct? Next, if there is some element, let's suppose we have 1 and 2, correct? So this is the you can say parent node, you can say, for the further children, right? Or if you'll talk about the level 1, so this is our, if you'll doing BFS, this is level 1, this is level 2, right? So this will be a parent of these children's, okay? And for this node, this is the root node, and you got, and these are called our child node, okay? Children's child nodes, right? Or leaf node, you can also say. Now think about the BFS. So we'll go first DFS, right? And if you want to go with the depth first search, you can tell me, okay? So first of all, we'll start from the depth first search, okay? So depth search, right? First of all, what we should do, we have to start with a node 0, right? So we have to, everyone have to go to node 0, because node 0 is what? Our capital city, right? Because we need to bring everyone to the node 0, because this is a capital city and all nodes should go here, right? All cities should come from here only, right? So we can model the graph as a tree that is rooted as node 0, correct? And the problem statement that we have given the hints, right, at this right, by stating that the network form a tree structure, right? And we can imagine that in order to move from one node to the root, all edges must be directed from you can say children to the its parent, correct? So if there is an edge from parent to its children node, no node in the tree, you can say subtree of the child, can reach from the root node, right? So this edge must be flipped, right? That's why we are doing all these things, right? So we have already seen that if some value we have given, like this is our parent node we have, right? And we have some children we have, let's suppose we have 1 3, we have given it is having 4, there is some value is 6, let's suppose this is 7 we have, right? Like this, okay? Direction is look like this one, and everything is look like so, and there is some value is there, right? So what we have to do here, we have to update what, let me change the color. So we have to change first, the direction should be this one, so that we can, everyone should go to what, this node, right? So this is our purpose, right, to understand, okay? So we must traverse the entire tree to determine the, you can say, number of such edges that directed from the parent to child node, right? If any any direction we have from parent to child, right, that we have to determine, right, that we have to see. So to traverse the tree, we can use a graph traversal algorithm that we call depth first search, right, and that we will use. So in DFS we use a recursive function, right, to explore the node as far as the possible each branch, right, from the each branches or each you can say place. So using or upon you can say reaching the end of a branch, we backtrack the previous node, right, and continue exploring the next branches. Means what I'm trying to say, see, in depth first search we use what, recursive function, right? Why? To explore the nodes, right, as far as possible along each branches. Okay, I think understood. So upon reaching the end of the branch at the last, you can say, we backtrack the previous node and will continue exploring the next branches. Got it? So each layer, if I'll, let's suppose I'm trying to, if I'll go here, I'll go with its children, this one, then I will go with its children, right, then we will go backtrack here and we'll explore its all children, right, like this. So this way we will do. So once we encounter an unvisited node, right, we will take one of its neighbor node if exist, right, as a, you can say, next node on this branch, right. So recursively we will call the function to take the next node at its starting node, and we'll try to solve this one, right. So you can say to count the number of edges, right, let's suppose our edges are directed. Okay, so to count the number of edges that are directed from parent to its children, right, if there is a parent, let's suppose 4 is directed to its 6, right, this one, from this is our parent and this is our child. Okay, so what we will do, we will count the number of edges that are directed from the parent to its children, right. We must traverse the entire tree, right. If there is an edge from you can say child to its parent, like we have here 7, right, child to parent, like this. Okay, this node. Okay, so if we want to traverse the actually we have to traverse the entire you can say subtree, you can tree, you can say, right, and if there is a edge from child to its parent, right, we will be unable to reach the child from the parent. Got it? So to traverse the entire tree, we must find a way to get from you can say node 0 to all the nodes in any case. Okay, so this is possible if the edges are treated as undirected. Okay, we have to check what this is undirected. We will treat this edges as undirected, right, and we add an opposite edge from node P to node A, right. We will do for every edge, every given edge, right, in a connection from node A to node B. What we will do, we will make, you can say, we will add an artificial edge, right. You can say, as you can see right here, this is nothing but our artificial edge that is in the red mark. Okay, so let us refer this edge, and that we add as an artificial edge, and the edge present in the connection, right, is an original, right. So whichever given in this connections, that is our original, but this is our artificial. So if we use an artificial edge to move from parent to the child node, we know that the original edge is the directed from you can say children to parent, right, child to parent. So we don't need to flip the original edge that we have given. We don't need to do the flipping. Okay, and if we use original edge to move from you can say parent to child, right, it means we need to flip this edge, correct. And whenever we encounter such an edge, right, we will increment our answer variable by 1, what I told. So if we use an original edge to move from parent to child, okay, so we need to flip this edge. So whenever we encounter such an edge, we will increment our answer variable by 1, and we will distinguish between you can say
original and artificial ages in many ways, right? Many different ways we have. By assigning a boolean, a specific numbers we can assign, right? You can do according to yourself, right? So we will associate an extra value with you can say each age minus 1 for original ages. Means for extra value we will do with the age, right? Let's suppose for original we'll use 1, and for you can say for artificial we'll use 0. Okay, so we can mark according to your choice. So we also set an answer, right, variable, that is we can say count equal to 0, and to count the number of edges that must be flipped, right, we start a DFS from node 0, and that is our root, and we will work on a way down to the tree from parent to child if we come across a original edge during the traversal, right? So what we'll do, edge level from 1, right, we will traverse to you can say 1 with a level with a 1, and we'll increase the count by 1. So we don't need you can say we don't need to modify count. If we come across an artificial edge, we can combine these two operation, count equal to plus sign, right? And whenever the sign is either 0 or 1 will indicate artificial or original edges, right? So better what we'll do, let's go to the you can say browser, and then we'll try to implement this one. Okay, so we are here, right? And first of all what we should do, we have given minimum order, and we will try to implement this one. Okay, so let's suppose we have map we have, right? And on the map we'll take first integer, and another will take list of what, our take list, and this list will take what, integer, right? And this is nothing but our adjacent list. We have created our adjacent cities, right? So we are going to create our adjacent cities, right? So these adjacent cities will contain all its neighboring cities, right? Has map. Okay, once this is done, right, what we should do, we will initialize our you can say adjacent cities, right, in the adjacent map, right? So what we will do, first of all we'll traverse our, we have given these connections. Okay, so I'll write connections, and from the connections what we should do, we should use 1D array like this, and this is nothing about a connection. So from connections will loop like this. Now what we should do, we have our adjacent, right? So adjacent cities we have on here only, we'll use compute if absent, compute if absent. Okay, this should work. Yeah, and here we should use our connections, right? So connection at 0, right? Connection at 0 is city 1, right? And we'll say cities, that is what we have, and it is what we'll take as a new array list of, you can say list of we have what we can say, yeah, array list of list, we can say list of list, we can say as a node, right? So it will be our integer, right? And then on these cities, right, what we will do, we'll add what, the first we will take there is arrays dot will do as a list, and we will add what, we have some let's suppose we have city 2, right, city and city B. So city B is nothing but our connections only.
So on the connection we have some value that is 1. So at 1 we have city 2, city B we can say, and we'll mark as 1. Correct. What I'm trying to do here is, see, I'm saying that we have this connection, right? So connection, this is nothing but our city A, okay, and at connection 1 we have what, a city B, okay. So we have city A and what we have, city B we have, right? So if we'll do join, then we have to pass our, is this a one way or is it directed or undirected, right? Sorry, directed in which direction? So I'll suppose I'll take 1 as a direction from A to B, okay, and similarly we'll take this one. Let me copy this one, okay. So here I'll use you can say from city B, and it's city, you can say A, right, and then we'll mark it as a 0, okay. So you have to define the direction, which direction is this, right? So we'll choose 1 and 0 for this way, okay, and this time we have initialized our you can say adjacent cities. Now adjacent cities are initialized. Now we will use DFS utility method, and this DFS utility method will start from you can say 0, and 0 is nothing but our root node, right? And I'll take -1 because root node doesn't have parent, and then I will use our adjacent cities. That's all. Once this is done, we will return our value, how many nodes we have to return, right? So I'll take first one you can say count, how many edges we have to count, edge update, edge direction, count edge direction update, edge direction update, and I will start from what, 0, and this count we have to return here, and that will update the DFS. So a DFS utility method will update this count, right, to count, you can say number of direction, edge direction we have to update, that we have to update from there. Now let me create this function because we don't have, so I'll create here, okay. Let me create the body. This method is not returning anything, but it is updating the, you can say, edge, and so we will return as a void, and 0 is nothing but our root node, so I'll take as a node for the current node, and this is nothing but our parent, right? So I'll say this is our parent node, and adjacency will be remain same. This is our adjacency map. I think we are good to go. Now what we should do, we will check first of all this node is on the adjacency or not. If not, we will return. So check if the current node not on what, this one. So I'll call contains key is a method. Why it is not coming? Contains key is a method. So contains key will store we can say this node, right? So if this node is onto the we can say onto the adjacent, then we'll continue. If not, then we will return. We will not do anything, we will break there. So this is our base case. Now what we will do, first of all we will go to the adjacent, right, and we'll check if this is on the adjacent, right? So if that is on the adjacent, just we have to make a loop, and on the loop we will check adjacent dot get this node and return its neighbor node, right? So I'll take neighbor node like this, and we'll say it will return in the it's a list, so it will return in the list like this. Okay, sorry, from here to here, no? From here to here. One, it should come here, one more. Okay, this is internal one, this is external one. Yeah, I got my mistake, so I have to update above. Why it was not coming, I got it. So we have to update here. Okay, now it will come. Let me check contains key is coming or not. Contains, it will come, don't worry. Okay, so now we have got our neighbors, right? NEGHBORs, neighbors. Okay, now we are getting neighbors node, right? Now what we will do, we'll check on the neighbors, right? We'll get our neighbor nodes. To get the neighbor nodes, what we have to do, neighbors dot, we will do get at index 0, and we'll get all its children. Okay, so we'll take int child and we'll say this is our child node, and from here what we will do, we'll find the sign, what sign we have, right? So we'll take int direction underscore sign, and this is nothing but our we have neighbor. On the neighbor we'll call at get at 1, what we have at 1. Okay, now we got, once we'll check if the given children that we have is not equal to parent, it's not equal to parent, correct? If it is not equal to the parent, right, then what we will do, we will continue. First of all, we'll say our we'll check our count, and we'll update its value equal to the, we have direction, right? Based on the direction, we'll update the direction from the direction sign. Okay, and yeah, if it is 0, it will not update the count. If it is 1, it will update its count, right? Again, we'll do the DFS similar way that we have done earlier. So now we are having its children, so this time we will go with the children, right? And it has parent now, that is nothing but our parent node and their adjacent. So what I'll do, I'll try to first compile this one. Okay, so what you have to do, first of all, make sure that you are using the correct one. The map will contain the integer and the node, you can say, and the list of list, right? So you have to closing should be 3 times, right? And similarly the adjacent will contain you can say list of you can say add list, right? And so this is fine, don't worry. And when you're coming back to here, make sure that we're using the correct one. And after that, when we are getting the value, right, so it should be return a list of neighbors, right? That's all. And submit this one now. Yeah, great. So let's understand about the complexity, right? So what is the complexity here? So we are traversing you can say all the, you can say, loop, right? So space complexity will O of n, because we are going with all the connections element, right? Means all the nodes we are traversing, and we're doing the recursive calls also, right? So all the nodes we are traversing, right, from parent to its children, right? So a space complexity O of n, and similarly the time complexity also O of n, because we are traversing all the space, and time is O of n. So thank you guys. If you like this video, please hit subscribe, and subscribe for more videos like this. And I used to regularly upload the daily Leetcode question videos, so hope you will like this video and you will continue with the same. And one more thing, if you want regularly on new topic, you can provide me, or any Leetcode questions you can provide me in the link, or you can do the mail to us. So please subscribe our channel and support to share the more videos and like this video. Thank you guys. Thank you so much.